All right, everybody, welcome back. We're going to be talking today about SR8, which is multiply and rationalize radicals. Now, this is going to be kind of like another one of a bring it back together after that long spring break. I know we have a tendency to lose track of some of these ideas, so I want to make sure we're all good before we move on. So, just like always, we're going to be trying to go through and write everything in simplest radical form. Now, when we come over here, we have the square root of x times the square root of x. Notice this nice multiplication symbol in the middle. Now, anytime you want to multiply radicals, we got to get one thing straight. When we wanted to add radicals, we needed to have like radicals, or some people call them like terms, in order to do that. When we multiply, we don't need to do that. We just got to be careful that we never multiply an outside number to an inside number or an inside number to an outside number. So in this situation, if you look at this thing, right, when you have this, we can actually multiply these two inside numbers together. X times x is going to give us x squared. Now, just like before, we always go through and simplify. This is the new part. I know we've done this. Where we're actually combining those by multiplying, but then after that we want to simplify. So x squared is of course just xx. You got two x's, you can pull one out. Nothing left inside the square root, so our final answer here is just x. Let's do another one. Let's amp up the difficulty. Let's use some bigger numbers here. So looking at this one, 13 times 26, both of those inside square roots. Remember, if you have two inside numbers, you can multiply them and they will form a new inside number. Magically, they don't jump outside. I'm going to need a calculator to help me out. So we get 13 times 26 is 338. Now, when you come over here and you try to break down 338, we got to use our thinking caps here a little bit. So 338, I believe 2 is going to go under there. So 338 divided by 2 is 169. Now, 169 might seem like a weird number to you, but I've done enough work with this to know that there's probably a 13 in there. So let's try taking 169 divided by 13, and oh my gosh, there was a 13 in there, and it went in there 13 times. Now, 13 is officially a prime number, just like 2 was, so we can rewrite the square root of 338 as 2 times 13 times 13. Remember, this is where you do your 2 for 1 special. You pull out your 2, you get your 13 on the outside, square root of 2, move along and have a great day. Nice job. Looking at number 5 here. So, square root of 54 times the square root of 24. So again, take your 54, times it by your 24. You're going to get a big number. Now, we can simplify that number. I do trust we know how to do that, but I want to show you another trick. Here's the other trick I'd like to show you. Let's just break down 54 for a second. 54 would be 9 and 6. 9 would be 3 and 3. 6 would be 3 and 2. 24, on the other hand, is going to be 2 and 12, which is going to be 2 and 6, which is going to be 2 and 3. Now, once you get those broken down, I want you to notice something. To actually combine these, another way to think about it is you can take all of these prime factors, 3, 3, 3, 2, 2, 2, 2, 3, and you can put them into one square root together already. So I'm going to put all my 2's first. So it looks like I had 1, 2, 3, 4 2's, 2, 2, 2, 2. And then I had 1, 2, 3, 4 3's, 3, 3, 3, 3. Now, coming on over, at that point, this is legal right now to sit there and combine in this way. Let's take our 2 2's, pull out 2. We can pull out another 2, so a 2 and a 2. We can pull out a 3 even, and we can even pull out another 3. And look, there's nothing left inside. So 3 times 3 is 9. 9 times 2 is 18. 18 times 2 is 36. Which is our final answer. That's a slick way to do it. Now again, if you wanted to come over here and multiply those and get 1,296 on the inside and break this down into whatever it factors into, you're going to get to the same answer ultimately, kids. Take a look at number 7. This one gets a little bit harder. We can think about it the same way if we wanted to, and maybe that's what I will show you. So coming over here, outside numbers just get multiplied. 5 times 2, that's going to be 10 on the outside. Now, for the inside numbers, if we take 2 times 45, that's going to give us 90. Now let's break down 90. 90 would be 2 and 45. 45 is going to be 9 and 5. 9 is 3 and 3. So when I rewrite this, I'm going to end up with 10 square roots of 2, 3, 3, 5. 2, 3, 3, 5. You got 2 3s, you pull a 3 out. Cancel these out. You're going to get 10 times 3, that's 30. And you are left with a 2 and a 5, which is going to, of course, make us a 10. Just like that, guys. Nice job. Let's look at number 9. Now, this is where we start to get to those harder multiplication. These harder ones require you to distribute. So let's come over here and do that. Remember, if there is no other inside number, the inside number is not going to change. So 7 and 1 are both outside numbers. 7 times 1 is 7. This square root of 3 can't be forgotten about. We got to just tack it on there. When we make our second multiplication here, we notice that that square root of 3 over here doesn't have a number in front, so I'm going to put a negative 1 out there, or put a 1 in front of it. Now, 7 times negative 1 will be a minus 7, and then since these are both inside numbers, they will multiply. The square root of 3 times the square root of 3 is 9. Now we just got to look at it and simplify. 3 will not get smaller, but 9 is 3 and 3, and I know that if I have 2 3s, I can pull a 3 out. There won't be anything left inside, so I'm going to get 7 square roots of 3 minus 21, because 7 times 3 is 21, right? And the square root of 9 was just 3 if you wanted to think about it that way. Let's take a look at the back page here. I know we got some rationalizing we're going to get to. Oh, one last good multiplying problem. I love this for us. Here we go. Ready? Whenever you see this, kids, this is a trick question. Anytime you want this, you cannot distribute this in. This is a trick question in math, and they're trying to get you. What you need to know about this is when you see this, this means write it twice. So I have 1 plus the square root of 3 times 1 plus the square root of 3. Now, multiply it out. 1 times 1 is 1. 1 times the square root of 3. That's an outside number times an inside number, so we just put them next to one another. Square root of 3 times 1. Again, an outside number times an inside number, so we just put them next to one another. Square root of 3 times square root of 3, that's going to give us a square root of 9. Now, as we come over here, hopefully you notice, hey, these are like terms or like radicals. So 1 square root of 3 plus 1 square root of 3 is going to give us, of course, 2 square roots of 3. And then the square root of 9 is 3. So this is going to be plus 3. 1 plus 3 is 4. So I get 4 plus 2 square roots of 3 as our final answer. Right? Those are the tough ones. Be on the lookout for them. All right, number 13, 15, 17, 19. These problems involve what we call rationalizing the denominator. Now, in order to rationalize the denominator, what you need to do is you essentially are trying to get rid of any square roots that are in the bottom of the fraction. We don't care if there's a square root in the top, but we do care if there's a square root in the bottom. So here's how we fix it. The trick we learned is that if we multiply by the square root of 3 over the square root of 3, that this will actually eliminate it from the bottom. So 1 times the square root of 3 will be just 1 square root of 3. On the bottom now, square root of 3 times the square root of 3, this is going to give us the square root of 9. And of course, we do know the square root of 9 in this situation. The square root of 9 is just a 3. So we can really rewrite that as the square root of 3, 1 square root of 3 over 3, and we are actually done. There is no more square root in the bottom. We've managed to move it to the top, which is just fine for what we needed to get accomplished. Looking at number 15. Now, I want to show you, you can use that same trick of multiplying top and bottom by whatever the square root on the bottom is. 1 times the square root of 144 will be 1 square root of 144. Now, something special that happens whenever you take a square root and you multiply it by itself, basically the square root drops off and you're just left with whatever number was inside. So down here on the bottom, square root of 144, square root of 144 is going to be just 144. So we can save a step and getting a big radical that needs to be simplified and write it just like that. Now, hopefully we do recognize, when I see 144, this is just the same as 12. So I don't need to write this. I can just write a 12. We know 1's hooked on to 12 by multiplication, so I'm going to get 12 over 144. Now, to go a hair further with that, if I have 12 over 144, that's a fraction that can be reduced. 12 goes into each of them. 12 goes into 12 once. 12 goes into 144 12 times. So my final answer will be 112. Now I do want to show you a quick shortcut. You could have gotten there a lot quicker on this problem. If you looked at this right away and you said, wait a second, I know that number. The square root of a 144 is just 12. Then you know your final answer would have been 112. And look it, we get the same thing, but with a heck of a lot less work, right? So we do want to take advantage of those tricks if we do see them. Square root of 17, or I'm sorry, number 17, which is 3 over the square root of 6. No tricks here. Rationalize the denominator. Remember, when you do this, square root of 6 is going to give us just a 6 on the bottom. Up top, 3 times the square root of 6 is 3 square roots of 6. Now, the radical can't be simplified. 6 is only going to break down into 2 and 3, and that doesn't help us out. But this is not a final answer. And the reason this is not a final answer is because of the fact 3 and 6 can actually be reduced. 3 goes into 3 one time, 3 goes into 6 two times. These are both outside numbers, so they get treated like a fraction does. So you're going to be left with 1 square root of 6 over 2, which will be your final answer. Here's our last question of the day. Here we go. 3 over the square root of 27. So let's take advantage of that trick. Multiply by the square root of 27 over the square root of 27. This is going to give us 3 square roots of 27 over. Now, square root of 27 is going to give us just 27. Looking at that radical up top, I do see we have some simplifying work to do. We can definitely make this simpler. So let's make this whole thing nicer. So I'm just going to pull it off to the side here and work down here kind of on some like scrap paper. 3 square roots of 27. 27 is 9 and 3. 9 is 3 and 3. Circle, circle, circle. So when I rewrite this, 3 square roots of 27 is a 3 on the outside and then a 3, 3, 3. We got a pair. Pull one out. Cancel it out. 3 times 3, that's 9 square roots of 3 right there. Now this is taking the place of this, so I can put 9 square roots of 3 back up top over 27. The last step, this is it. Look at the outside numbers. If they can be reduced like a fraction, you need to reduce them. And in this case, we can. 9 goes into 9 one time. 9 goes into 27 3 times. So our best answer here is 1 square root of 3 over 3. And that is it. Thank you guys so much for watching the full video. Remember, your job is going to be to go and take care of the evens. Thank you guys so much. Have a great day. Keep me posted if you're having questions.